Hi everyone, Engineer Liu here. So as you can see from the previous video, there's pretty much a lot of ground to cover when regarding strings in C, and because their functions from the string.h library are not really that safe, so we have to be very careful when writing C programs that works with strings. So we asked on the previous video ChatGPT to write a safe version of a function from string.h library for us, and we were successful in doing so. So as you can probably guess, most of the functions from string.h library are not safe, and so to summarize all it up, you have to be very careful when using them. So yeah, so for this video we'll cover some other functions from string.h library which we haven't talked about at all. So let's take a look at the manual. So we cover string compare to check if two strings are equal, and string concatenation. Well, we can talk about string copy, which copies a string from source to destination, which we use on our video about the ChatGPT. ChatGPT wrote us an example using its safer version of a string cat, which use string copy, so we can talk about that. Also, an important function, there is a function to compare, to check if a character is present in a string, to check if there is a substring within a string. So yeah, there's pretty much a lot of ground to cover, so let's get started. Okay, so we include standard io.h, include string.h, and we create our main function. And let's say we have as from the previous video, we define a size, a buffer size, say, of 256. And yeah, we'll create char string 1 of buffer size, and then we create a let's name it buffer, and let's say we create a string char string of let's say hello world. Okay, right? And then we can copy this string into the buffer, right? So basically how it works is string copy a buffer that we want to pass, and then the string, and then we can print the contents of the string. So we'll print off buffer contents, and we pass in the buffer, and that's pretty much it. Okay, so let's check. Okay, so let's compile first, because as you may guess, there's a problem with string copy, and yeah, of course it is unsafe, and yeah, you will get hacked if you use this function. Okay, so let's try it. Example 23.c, example 23.o. So yeah, no warnings. No, okay, no warnings. Okay, buffer contents hello world, right? Okay, so what will happen? Okay, so let's count how many characters we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, counting the no terminating character, right? Okay, so we have 13. Let's say we have here, instead of 256 bytes available in our buffer, we have 8. Okay, so it's less than the string we want to copy. Will this program break? What happened? Yeah, it didn't break, but it actually wrote in part of the memory where it shouldn't be writing. So yeah, you will get hacked if you use this function, so don't use it. What we can do is we have a version of a string copy, which is string and copy, which takes the size n. So as the manual says here, string and copy function, it's similar except that yeah, here a string and copy string of overlap, this just a string that must be large enough to receive the copy. Beware of buffer overrun. So yeah, don't use it. Okay. So string and copy function is similar except the most n bytes of string of source are copied. Warning: if there is no null byte among the first n bytes of source, the string placed in the destination will not be null terminated. Which means that we can have unpredictable behavior or yeah, wired pointers and stuff, and yeah, we can probably still get hacked. Okay. So if the length of source is less than n, string copy writes additional null bytes to destination to ensure that a total of n bytes are written. Okay, and simple implementation would be there's an example: string and buffer. If buffer length is greater than 0, and then we'll use string copy. Yeah. So if there is no terminator, as it would say before, no byte and no character, the first n byte of source, string and copy produce an unterminated string in destination. Okay. So if buffer has length buff length, you can force termination using something like the following. Okay. So this will guarantee that we don't have unpredictable behavior when working with our string. Of course, the buff technique ignores the fact that if source contains more than buff length minus 1 bytes, information is lost in copying to destination. So yeah, you have, as I was commenting on the other video, on the previous video, you have to make sure that your buffer has enough bytes available to copy into a string. Yeah. So you should always take a look at the manual page of the standard C library, because they, as you can see, they're very useful. So I guess I will use this code snippet here into this code. All right. So yeah, let's copy right here, format. Properly. Okay, yeah, let's raise that to 32 bytes. So here we won't use this function anymore. You can completely forget about it because it's unsafe, it's not safe. So you can say that size of buffer, which is our string here, which acts as a buffer. If it is greater than 0, then we use string copy to our buffer and the string, and then size of buffer minus 1. Okay, and then we ensure that our our buffer ends with the new character, okay? So we don't have any sort of, as I was saying, any sort of unpredictable behavior for our program, right? If size of buffer, rise to string copy, and yeah. So let's try it out. We compile and run. Yeah, it works fine. So let's try having a buffer which can't accommodate all our function. And yeah, as you can see, it truncated the string we tried to copy to our buffer, and because it didn't have enough room, enough space and bytes. So as it will only had 8 bytes, it wrote H1, 2, 3, 4, 5, 6, 7, and then one more byte for the new character, okay? Because that's how the C program knows that your string has ended in the memory, okay? So you can imagine each byte in memory for a string stored continuously, and then when it's reading, it encounters the null character, and then it knows, that's how it knows that your string has ended, okay? So you don't have unpredictable behavior. So let's say that our string hello world does not have let's try to mess up with this up a bit, okay? So let's go back to 32, and here we have 13 counting the null character. Let's say we have 12, and we don't do this over here, okay? So we don't add the null character. So what can happen? Okay, so apparently it works, everything is fine, but there is actually, so we expect here this to have when you compute the string length of this string, it will result in 12 as a string length. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters, so it will give us 12, right? But since we don't have the null terminating character because we didn't leave room for it, we can run into some problems, as you can see as we talk about our implementation of string length. Okay, so let's try it out. String length of buffer, it's long unsigned int, and we compute it. Okay, so we expect this to be equal to 12, right? Yeah, so it worked apparently. So let's try it. It's 11. Initial warning: initial largest string for array of char is too long. Okay, so now we got ourselves a problem, because even though we didn't leave room for the null terminating character, C will create additional room when for the stack, because we are not allocating memory dynamically, and then as it will see that we have a 12 here and 12 here, and then it will add one more byte in the stack for the null terminating character. So yeah, it gives us a warning. So yeah, we can expect unpredictable behavior here. And yeah, buffer contents, hello world, we would expect here 12, but we got 11. So let's try it with this line over here. And then yeah, we still got 11, so which is incorrect. Okay, and then let's yeah, modify to 12, and then everything will work again smoothly. Okay, so let's try one more thing. I want specify the size of the string, and we just initialize a pointer like this. And I believe that he won't, so it didn't give us any warning, but he won't create a new character for us. So let's try. Yeah, apparently it did. Okay, but you shouldn't count on that. But it worked nevertheless, right? Yeah, so regarding string copy, this is basically it. And yeah, this video is almost 16 minutes. We can stop it now. And on the next video we can talk about checking for chars and strings, substrings, and as well as tokens and so forth. So yeah, beware of strings in C. I know I've been repeating myself a little bit over the videos in this regard, but it's a serious topic, and buffer overruns can make an attacker and a hacker can possibly get control over a whole server, a whole computer with this by remote code execution, just because you forgot that you forgot to check your buffer size and write part in the memory that wasn't supposed to be written. Okay, so keep that in mind, and yeah, be careful. So hope you guys liked this video. Don't forget to like, subscribe, and comment, activate notifications, and see you next time. Bye.